Hello guys, we want to start our 16th lecture today. So in this lecture, I want to talk about transform of an integral. So let's go to see what transform of integral is and then solve some examples. So transform of an integral, Laplace transform of integral from 0 to t, f alpha d alpha is equal to f s over s, or is equal to Laplace transform of ft over s. You know, in your textbook, your textbook uses different notation. So instead of alpha, it has tau. So in fact, Laplace transform of the integral from 0 to t, f tau d tau, it's equal to Laplace transform of ft over s. So it's the notation of your textbook. And we have we have inverse of a transform of integral. So Laplace inverse of fs over s is equal to the integral from 0 to t f alpha d alpha. Let's use a transform of integral to solve one example. So we want to find Laplace inverse of 1 over s times s squared plus 1. In order to solve it, so we have Laplace transform of 1 over s times s squared plus 1. So it's equal to Laplace inverse of 1 over s squared plus 1 divided by s. It's equal to Laplace inverse of, if I want to simplify it, fs over s. So what's fs here? Fs in this case is 1 over s squared plus 1. If fs is 1 over s squared plus 1, ft, which is Laplace inverse of fs, it's equal to Laplace inverse of fs. So it's equal to sine t. As a result, so Laplace inverse of fs over s, based on definition of transform of integral, it's equal to the integral from 0 to t f alpha. Ft is equal to sine t. As a result, f alpha is sine alpha d alpha. So the integral of sine is minus cosine alpha from 0 to t. So it's equal to minus, I have to apply upper limit, cosine t minus 1, or it's equal to 1 minus cosine t. So we could find Laplace inverse of this function using transform of integral. But in this problem, you can use partial fraction decomposition to solve the problem. But I wanted to use the transform of an integral. So let's go through the next example. In this example, you want to find Laplace transform of the integral from 0 to t, tau sine tau d tau. So in order to solve it, we use two properties of Laplace transform. The first one is transform of integral So we had it here. So we said Laplace transform of the integral, Laplace transform of integral from 0 to t f tau, let's use f alpha d alpha, it's equal to Laplace transform of ft over s, or f capital S over S. The second property that we have to use, so it's a derivative of transform. It's derivative of transform. So we had it in the last lecture. We said Laplace transform of t to power of n ft, it's equal to minus 1 to power of n dn dsn Laplace transform of ft. So we have to use these two properties to solve the example. Let's go through the example. So we want to find Laplace transform of the integral from 0 to t tau sine tau d tau. Based on transform of integral, we have the integral, and we have Laplace transform of integral. It's equal to Laplace transform of f divided by s. So as a result, it's equal to Laplace transform of ft. So we have f tau is tau sine tau. As a result, ft is t sine t divided by s. Here we have to find, if you see here, we have to find Laplace transform of ft, but in this case, tau times sine tau, it's f tau. So as a result, now I have f tau, so I have to find ft. So ft is equal to t times sine t. So now we have to find Laplace transform of sine t. Laplace transform of sine t based on derivative of transform is equal to, so denominator is this s. In numerator, so we have t, you have to just compare it with derivative of transform, this equation. So t to the power of 1, as a result, we have minus 1 to power of 1 d over ds Laplace transform of sine t. It's equal to, denominator is s minus d over ds Laplace transform of sine t is 1 over s squared plus 1. It's equal to, denominator is s. So if you want to find derivative of 1 over s squared plus 1, so it's s squared plus 1 squared. We have 1 minus here, so I have to keep it here. So derivative of numerator times denominator is 0 minus derivative of denominator, so which is 2s times numerator. So if I want to simplify it, we have 2s over s times s squared plus 1 s squared.